In this video, I'm going to talk a bit about density. So the density is the mass of an object per unit volume, and that means that we find it by taking the mass and dividing it by the volume. And density can be used to identify an object. So the density of an object is specific to that compound. Density can't be used to conclusively identify something, but it can be used as a particular data point in identifying what an object is. So for instance, these different elements have their own unique densities, and so if you get the density of some object along with probably some other data, you can use that to help identify what the object actually is. And it can also be used to determine whether an object will sink or float. So objects that are more dense than whatever it's in will sink. If it's less dense, then it will float. So you may have seen something like this before, where Coca-Cola will actually sink in water and Diet Coke will float in water, and that is because Diet Coke is less dense than the water, where Coca-Cola is more dense, and that's because of the fact that Coca-Cola has a bunch of sugar in it, where Diet Coke has artificial sweetener in it, which is a lot sweeter than the sugar, and so you don't have to put as much of it into it, and so that means it will actually be less dense than the water and therefore float. But one of the things that we're going to be focusing on here is using this as a conversion factor. And so this can be used to go from volume to mass or from mass to volume. So it can be used as a conversion factor between volume and mass. And so some common units for this in solids is usually in grams per cubic centimeter. And solids are often, but not always, more dense than liquids or gases. And liquids, we oftentimes use grams per cubic centimeter or grams per milliliter. And in metric, this is nice because a cubic centimeter is just equal to a milliliter. So it's pretty easy to convert between those because it's just 1-to-1. And especially if you maybe have seen like medical shows and stuff, you hear people talk about cc's. That just means centimeter cubed. So that is just the same thing as the cubic centimeter and the milliliter. Gases, which are often a lot less dense than liquids and solids, we use the liter for the volume unit on it. And that's because we want to capture a lot larger amount of the gas in order to get the density, whereas if we were doing something with milliliters or cubic centimeters, that's such a very small volume that it would be hard to actually get a good reading on the gas for it. And so when we're thinking about density, we call this an intensive property, which means that it does not depend on the amount of stuff that's there, whereas things like mass and volume do depend on the amount that's there. So for instance, if we have this large block here on the right that's composed of a bunch of smaller blocks that are all 1.20 grams per milliliter, we want to know what the volume of this larger block would be, what the mass of this larger block would be, and what the density of this larger block would be. And so to get the volume, we just multiply it by the number of small cubes that are there. And so remember, when we're doing a counting, we don't have to take significant figures into account, because when we count, that just means we have infinite precision on there, and so we end up with 3 significant figures here. And so we're just taking 27 of these blocks, stacking them together, and so the new volume of this larger block is 27 milliliters. The mass, we take the density of it, 1.20 grams per milliliter, and multiply it by the number of milliliters in that large block, and that gets us 32.4 grams. So this larger block is going to be 32.4 grams and 27.0 milliliters. So we have scaled up both the volume and the mass of it. But if we do the density, we just take the new mass, divide it by the new volume, and that just gets us, again, 1.20 grams per milliliter. And so we see that no matter how much of this stuff we have, whether we have just this smaller block or this larger block, the density actually remains the same. And so that's what we mean by an intensive property, in that it does not depend on the amount of stuff there. The density will always be the same no matter how much of the stuff that you actually have. Another way to think about this is if we have something that is the 1.20 grams per 1 milliliter, then when we double it, we're just multiplying everything by 2. So we're just increasing the volume by 2, and we're increasing the mass by 2. So both of those are increased by 2. But then both of these 2's cancel out. And so that just simply gives us back our 1.20 grams over 1 milliliter. And so now to go through a few examples here of how to actually use density. So if we have something that is 25.9 grams and has a volume of 35 cubic centimeters, so we want to find the density here. That's going to be our mass over volume. So that'll just be the 25.9 grams over the 35 cubic centimeters, and so that would give us the 0.74. So that's two significant figures because this 35 cubic centimeters is two significant figures, and that will just end up being grams over cubic centimeters. So our units just end up being however we arranged the units in our problem here. So it's grams over cubic centimeters, so our units are grams per cubic centimeter, and we can also write it like this. So this is often how you see it written, with it more linear or horizontal like this. So it's 0.74 grams per cubic centimeter. But now if we want to use this density as a conversion factor, we can use it with one of our problem approaches here. So what is the volume of an unknown liquid in milliliters if its mass is 4.89 grams and its density is 1.21 grams per cubic centimeter? So the number we're trying to convert here is our 4.89 grams. Our answer we want to have in units of milliliters, so it's asking us to get it in milliliters. And the conversion factor given in the problem is the density here. So that's the 1.21 grams per cubic centimeter, and we can just look up or just memorize the fact that 1 milliliter is equal to 1 cubic centimeter. And so when we do this, again, we want to start with our measured value here, which is the 4.89 grams. I put it over 1 just so it lines up nicely for canceling units. And then we use this. So we know we have to have grams in the denominator on the next factor here. And so we just use the density here and put the grams in the denominator. So 1 cubic centimeter over 1.21 grams. And so then we have to have the cubic centimeters in the denominator on the next one. And so we can just use the 1-to-1 ratio for cubic centimeters to milliliters. The grams cancel out. Cubic centimeters cancel out, we end up with milliliters, which is what we wanted, and so that ends up being 4.04 milliliters. And this, again, is in three significant figures. Our measured volume was in three significant figures, and so our answer should have three significant figures. And so that's how we can use the density to go from mass to volume. We could also use it to go from volume to mass. So for instance, what is the mass of an unknown solid in grams if it displaces 27.31 milliliters of water and its density of 0.878 grams per milliliter? And so we see this here. It says it displaces this amount of water. So this gets at what's often used to find the volume of solid objects. You put it in water and look at how much the water goes up. And so however much the volume of the water increases, that's what the volume of your solid is. And so that's what we mean by displaces. So in this case, the number needing conversion is our 27.31 milliliters. We want units of grams, so it's asking us what is the mass of the solid in grams. The conversion factor is our density, the 0.878 grams per cubic centimeter, and we don't have to look up any units for this. So again, we start with the thing that we're trying to convert from. So that's the 27.31 milliliters, and that means we know we have to have milliliters in the denominator of the next factor, and so we can use the density this way. And so then we cancel out the milliliters in this case. We're left with grams, which is what we wanted, and that gives us 24.0 grams. And so in this case, our density was at three significant figures. So remember, density is something that actually has to be measured, and so that means that we do need to take its significant figures into account. So this had four significant figures, this had three, and so we need to go with the fewest number of significant figures. So our answer should be in three significant figures. But anyway, that was everything I wanted to talk about in this video. I hope you found that helpful, and I will see you in the next one.